So I'm going to walk you through the final exam practice review sheet. Starting with section 1, I'm going to skip over all of this description at the top. You can, of course, read that in your own time. We're going to walk through each of these different questions, and I'm also going to try and show you in the textbook where you could go to get more information about that question, or where you could look to have answered that question if you're struggling with it. So the first question is asking about the summary statistics, and you have the line of code here that I used, pulling out the summary statistics in MA schools, specifically the variable EXP expenditure total, so the total spending. And so this is the total spending at schools in Massachusetts. And so the first question asks, what is the average total spending at schools in Massachusetts? To figure out that question, if I didn't have a great idea, I'm looking at chapter 10, descriptive statistics, and a little ways down here, I talk about the mean and the median. And the mean is, of course, equivalent to average, and so I'm asking you to sort of interpret that a little bit. And so what is the average? What is the mean in this data? You can find that right here under mean, so 5370. The second question asks you for the highest total spending. Highest, of course, is another word for maximum. What is the largest number in this variable? And so down a little ways, we talk about max, we talk about min. So if I asked about the lowest, that would be the min, but I've asked about the max, and so that would be 9868. Second question asks about this graph. And the first thing I ask is, what kind of graph is this? And so if I wanted to review that, I would go to the chapter on displaying data. And the first thing I'm asking is for you to identify the kind of graph that I've shown. I don't give you the line of code. And so you could flip through this and try to see, do any of these graphs look like that? Wait, this one looks pretty similar. And this is, of course, a scatter plot. Then I ask in one or two sentences, can you tell me the story of this graph? There's a lot of different sort of specific ways you can write it, but generally what this graph is showing is that as median parental income gets higher, fourth grade test scores get higher. And if at the lower end, they're both lower. And so there is a positive relationship for median parental income and fourth grade tests. As income goes up, test scores go up. Any sort of variation of that, describing that there is a relationship shown by this graph, and that as one goes up, the other one goes up, that will get full credit. The next thing I ask is about correlation. You'll probably notice that I'm moving through these chapters somewhat in order, although I come back to polling at the end, just because I can't use quite the same data for that. So we're skipping the chapter on polling for the moment and going to correlation. So the first thing I ask is, what is to interpret the correlation between salaries for teachers and scores in 8th grade using this line of code, which I've copied in, and this is the output. So the correlation between salary and 8th grade test scores is 0.433. And so I'm asking, are those correlated? And describe both the direction and strength. And so that's referring really specifically to this table down here about the strength of correlation. So I might say the correlation coefficient is 0.43. That is a positive correlation, right? It's above 0, so it's positive. and it's moderately strong because it's in this area between 0.41 and 0.6. It is a positive and moderate correlation. I then give you this correlation matrix, which we talk about as a way to show the correlations between multiple variables at the same time. And that's right down here, the correlation matrix. And so what I want you to pull out of this is which two variables have the strongest positive correlation, and then separately which two have the strongest negative correlation. And the strength of correlation is always the distance from zero. So a variable that has a 0.9 correlation, or two variables that have a 0.9 correlation, or that have a -9 correlation. Those are both really strong correlations. It's always the absolute distance from zero. And so I'm asking you to look across all of these numbers and figure out which number is the largest in a positive direction and which one is the largest in a negative direction. And so it looks like the correlation here, 0.857 between test scores in 4th grade and 8th grade, is the strongest positive correlation. That's the largest positive number on the correlation matrix. So score 4 and score 8. And then what is the strongest negative correlation? So what's the largest negative number on the correlation matrix? And that looks like it's 0.58. There aren't a lot of negative correlations on the matrix. And so 0.58, which is between score 4 and English. Now we're moving to regression. So I give you this regression output. This is the line of code I ran to produce this regression. So I ask you to interpret these results when regressing salary, which is the independent variable, on test scores in 8th grade, which is the dependent variable. And so I give you this sort of this formula, this guide for interpreting regression output that I use in the book. And so you can use this to sort of fill in your answers. And so for each 1 unit increase in, we want to put the independent variable here. So for each 1 unit increase in salary, we observe and this is where we want to put our coefficient. So our coefficient for salary is 2.8966. You can either round that or put all of the decimals. 2.8966. Increase. It's a positive number, so we know that the independent variable is associated with an increase in the dependent variable. So we observe a 2.8966 increase in our dependent variable, which is score 4 or score 8. And that change is significant. 3 stars here means that this result is highly significant. So let's take the isn't away, and let's read that once through as a complete sentence. So for each 1 unit increase in salary, we observe a 2.8966 increase in 8th grade test scores, and that change is significant. The next question asks, and if you wanted more sort of information on that and that interpretation, right, I go over the output and identifying all this information here, statistical significance. I talk about how to read the stars and what those mean. And in the practice, we go over a few examples of using this guide to interpreting the regression. We then go to multiple regression. We start with a sort of discussion of bivariate regression again. And then later on, we get to sort of how this idea of holding something constant changes our interpretation of each variable. And so now I'm asking you to interpret one of the independent variables while holding others constant. And so we've got this output. This is the line of code I used to run this regression. So interpret these results when regressing salary on test scores in 8th grade, and I give you the sort of guide again. And so there's one thing added from above. Now we need to sort of identify what we're holding constant. So for each 1 unit increase in salary again, I'm only asking you to interpret one of the independent variables. For each 1 unit increase in its salary, we observe a negative 0.02475. So 0.0245 decrease, right? The coefficient is negative. So now we're observing a decrease in score 8. When we hold income and lunch constant, we're holding the other independent variables constant while we're interpreting salary. So we're holding income and lunch constant, and that change is no longer significant. That change is not significant. So for each 1 unit increase in salary, we observe a 0.0245 decrease in score 8 when holding income and lunch constant, and that change isn't significant. So for the final question, because this is going to just have to use different data than MA schools, I go back to polling. And so this final question is just asking about some data where I give you sort of all of the information you need. And I ask you, I tell you that candidate A has 52% of voters and candidate B has 47% of support amongst voters. And the poll has a margin of error of 3 points. So you can think about drawing this out yourself. So candidate A has 52% of voters, plus or minus 3. So the actual support might be up to 55, but it might also be as low as 49. I don't know how there we go. And candidate B has support from 47% of voters in this poll, but that's plus or minus 3 points. And so that might be as high as 50, and it might be as low as 44. So the question becomes, right, can we conclude anything about this? Do we know that candidate A is leading or candidate B is leading in the population beyond this poll? We know that in the poll, candidate A was leading with 52% of the support. But are we confident that that candidate A is actually going to win in the election? Because the margins of error are 3 points, they overlap here. So candidate A might be as low as 49, candidate B might be as high as 50. And so there's a chance that just based on what we know from this poll, the candidate B is actually going to win. And so we can't really conclude the candidate A is leading amongst voters beyond what we got in this poll. And so that's sort of the conclusion, that it's an unsatisfying conclusion that do we know anything? No, we don't really know much based just on this poll. So that's section 1 of the final exam prep. And in the next video, I'll go over section 2 where I ask you to do some of the output yourself. And so I'll walk you through entering that in R.